waste management is one of the basic concerns these days, that with the high strength as well as the cost-effective materials. So, being an agricultural university, like livestock wastes like cow dung, chicken feathers, waste residues are easily available. So, my concept was to develop the best out of waste from the minimum resources available. That is a sustainable waste management. In my current material development, I use the chicken feather as a fiber, whereas I have used fish residue as a particulate to make a hybrid biocomposites. So what exactly the composite is? Composite is a material system composed of two or more dissimilar metals that are insoluble in each other, that are physically distinct and chemically homogeneous. For my work, I have used a composite which is a fiber reinforced, discontinuous and are randomly oriented. And for hybridizing, I have used a particle reinforcement that has been dispersion strengthened. What exactly the hybrid composite is? Hybrid composite is mixing of two or more fibers or two or more particulates or the vice versa to make a material which has an enhanced property as compared to the other available materials. In my work, I have used matrix as epoxy, livestock with chicken feather as a fiber, and fish residue. I have converted the fish residue into a powder. So let me tell you why I use the composite. Composite can have n number of applications, like it can be used for mechanical, structural, electrical or the interrelations of each and everything. It improves the weight power to weight ratios. It has a better acoustical properties. Efficient utilization of material can be done. And the desirable properties can be obtained with the help of developing composites. Why I used particulate as fish residue? Because by the testing we did it at IIT Roorkee from the FE7 thermal analysis, we got that epoxy, the major constituent that we have used, had a melting temperature of 230 degrees centigrade. But the particulate which has the elements like carbon, nitrogen, silicon, phosphor and calcium that we got from the FE7 analysis, it has a very good decomposition rate. That means it has a very good thermal stability. It can withstand even a temperature of 900. You can see from the figure at 849 degrees Celsius. It has just decomposed 5.3%. And why I use chicken as a feather? Because it is easily available. Also, the major problem with the livestock waste is that burning. It can be decomposed by burning or burning, and both have the problems. So, and it has also a good thermal and acoustical properties. So that is why we use chicken feather as a fiber, and all these kind of feather like Colombian, Guinea, white Gagan are easily available in our university. The research objective was firstly the making of the particulate, then making of the fiber, and then casting it for the feasibility study. For feasibility study, I have used epoxy and the chicken feather fiber, and with the best percentage of chicken feather fiber, I have made it a hybrid biocomposite by varying the weight percentages of fish residue. This was the methodology, like first the cleaning, then heating. This was the step-by-step process that I have used in developing the material. This was the prepared samples with different weight percentages of the sample. After the samples are been prepared, based on the ISO standards, we have done n number of different characterizations like physical, mechanical, morphological and thermal analysis. These are the short results that I have mentioned here for the feasibility test. And we have seen that through the logger and impact test, the maximum percentage it has been continuously rising, and the maximum improvement was shown at 5-8% of chicken feather fiber. So taking 5-8% as a feasible solution in both impact and hardness test, what we did is we made a hybrid biocomposite by varying the weight percentages of the particulate. Later, hybrid biocomposite was prepared with varying weight percentage of particulate from 0 to